All right, today's lesson is lesson 4.1, and we're going to be learning about rates. So open up your book to page 150, and it'll follow along with our book. So we have a little story at the beginning of the chapter section. It says, the Lawsons are going camping at Rainbow Falls, which is 288 miles from their home. So their trip is going to be 288 miles. They would like to reach the campground in 6 hours. What should their average speed be in miles per hour? So they want to get there in 6 hours. How do we figure out how fast they need to go? So what we're going to do is divide 288 by 6. That seems easy. What we're learning here is our unit rate and how to make sure we are putting our units into our answers. It's important that we are using our units and that we're practicing writing those units in, because it's going to become more important the further we go in math. It's also important in things like science and engineering when you are using different types of measuring systems. So we'll figure out how fast they have to drive, and we'll take 288 divided by 6, and gives us 24. 8 minus 4 is 48, and 6 goes into 48 8 times. So they have to drive an average of 48 miles per hour. Okay? Or another way you might see this written, miles per hour. Okay? So the math is easy, but it's making sure that we're putting those rates into our answers. All right? And yes, you're going to have some bigger math problems like this, bigger numbers. I think you can handle it. Okay, so our first example problem, besides the word problem at the beginning, is during exercise, Sonia's heart beats 675 times in 5 minutes. So 675 beats divided by 5 minutes. Okay, so let's do the math real fast. 6 into 5 is 1, 17, 3, 5. So it's going to be 135 beats per minute. You could also write it, you can write it beats per minute, or you could do 135 beats over minute. That works as well. So you can write it all out, or you can write it in fraction format. Either way, Sonia's heart is beating 135 beats per minute. Okay, example 1b, says to make 4 large pizza pockets, Paul needs 14 cups of broccoli. How much broccoli does he need for 1 large pizza pocket? Okay. These are not our average unit rates. We don't generally have broccoli per pockets as a scientific rate, but that's okay. We can use that. So we have 14 cups of broccoli divided by, he wants to make 4. So 14 divided by 4. We know that 4 goes into 14 3 times. That gives us 12, and then 20, and 5. So he's going to need 3.5 cups per pocket. Okay, 3.5 cups of broccoli per 1 pizza pocket, or cups per pocket. Okay. An average rate of speed, so moving on to page 155, it says an average rate of speed is the ratio of distance traveled to time. The ratio is a rate because the units being compared are different. Okay, so the Lawsons, this was the problem we did earlier. So they worked out this problem from the beginning, which we had already found to be 48 miles per hour. Now, what they want you to know is that they were not driving 48 miles per hour the entire time. That's just the average of their slow speeds and fast speeds in order to make it 288 miles in 1 hour. Okay. We generally, when we are talking about speeds and distance when we're traveling, it is generally an average speed because you have to start slow. You can't start at 60 miles per hour. And and you have to slow down at the end of your driving place. Okay, and the last one, it says the Lawsons on their road trip stop at a roadside farmer's market. Maybe this is why their average speed was so low. The market offers lemonade in 3 sizes. So you can see on the side, they got 12, 18, and 24 ounces. Which size lemonade has the lowest price per fluid ounce? So what you're going to do is you're going to take the price of each one and divide it by the number of ounces to find which one has the lowest unit price. So the first one is 0.89 divided by 12. And we know 12 times 5 is 60. And so 12 times 7 is going to be, 7 times 2 is 14. And it's going to be 84. Subtract from that. It's 5, 0. So it's going to be 4. This is money we're talking about, so we have to round. So it's going to be, 0.07 cents per ounce. Okay, that's for the 12 ounce. Now let's do the math for the 18 ounce, and that's $1.69 divided by 18, and 18 does not go into 16, so 0, and then 169, try 9, times 8, 73, 9, so 163, 9 minus 3 is 6, 0. That's going to be less than 5. That's all we need to know. So the next one is 0.09 cents per ounce. Okay, so 9 cents per ounce, 7 cents per ounce. So this one is still the cheaper one. Which generally, most of the time, if you order something larger, it's supposed to be that you're getting more a cheaper price, but apparently not at this roadside stand. All right, so the next one is 2.09 divided by 24 ounces. Okay, 24 does not go into 20. This is going to be, let's see, we know that 25 goes into 100 4 times, so 4 and 4 is 8. That's the wrong number. So let's try 9. 9 times 4 is 36. 9 times 2 is 18. It's 21. Okay, so it's not going to be 9. I also don't think the book has the right answer. Because they have this as 0.9 cents, but 9 doesn't work. That would be an 8. Oh, but we're dealing with money. So I bet if you go further out, it's going to round up. Let's see. So 24 times 8. So 4 times 8 is 32. 16 and 3, 19. So 1, 9, 2. And that gives us a 7, 1, bring down your 0. Yep, it's going to round up to 0.9. So if, let's see, let's try 24 times 7. 7 times 4 is 8, 2, that's going to be 16, yep. So that's going to round up, and again, 0.09 cents per ounce. So, which is the cheapest size to get in terms of cents per ounces? It's going to be the 12-ounce drink. Okay, because you're only paying 7 cents per ounce. The other two, you're paying 9 cents per ounce. So you are paying more for those bigger sizes per ounce of liquid. Okay, so for this section, please make sure in your answers that you are writing down your unit rates. You will get the answers marked wrong if you don't have unit rates. Okay, so go ahead and move on to your assignment.